science fiction can sometimes influence the course of science. In 1941, author Isaac Asimov published Reason, a short story in which two astronauts, Powell and Donovan, try to train a robot called Cutie to operate an energy station in space.
The dots to which our energy beams are directed are nearer and much smaller. They're cold and hard, and human beings like myself live upon their surfaces, many billions of them. It's from one of these worlds that Donovan and I come. Our beams feed this world energy drawn from one of these huge incandescent globes that happens to be near us. We call that globe the sun, and it's on the other side of the station where you can't see it.
In this passage of the story, Powell is speaking with Cutie, describing the orbiting solar power satellite that beams energy throughout the solar system. This is the station that Cutie will have to control.
The rest is simple. When these stations were first established to feed solar energy to the pallets, they were run by humans. However, the heat, the hard solar radiations, and the electron storms made the post a difficult one. Robots were developed to replace human labor, and now only 2 human executives are required for each station. We're trying to replace even those, and that's where you come in.
A system like the one described by Asimov does not yet orbit above our heads. For now, solar energy is terrestrial. It's here on Earth with us. Still, this concept has moved beyond the pages of science fiction to become, if not yet a reality, at least the focus of many research and development programs and a major topic of discussion. Today, we know it as space-based solar energy. Welcome to Euronews Tech Talks, the podcast that explores the digital, technological and scientific landscape shaping Europe. I'm your host, Euronews science correspondent Jeremy Wilkes. Today we continue our journey into the world of space and energy. After looking at nuclear power on the moon, we're now tackling another complicated yet fascinating topic: space-based solar energy. We'll speak with multiple experts, and you'll hear different perspectives on the idea, and above all, you'll hear facts and analysis that we hope will answer your questions and spark your curiosity. As always, we'll try to navigate our way carefully through a polarizing subject and investigate the blurred lines between science and science fiction.
Space-based solar power, or energy from space, is the concept of putting solar farms in orbit in order to collect sunlight and beam it wirelessly down to users on the Earth. This can also be done to other destinations, like the moon or even in space, but it's been typically considered as a source of energy for Earth, which is an advanced form of solar power.
This is Sanjay Vijendran, co-founder and CTO of TerraSpark, a European private company specializing in space-based solar power.
In order to put a solar farm into orbit, you can imagine the solar farms that you see in the countryside. They can be relatively large, and you want to capture a lot of power in space because we have huge energy needs here on Earth. So as a result of needing to build large structures in space, you're not able to launch it as a single structure on a rocket into orbit. So we have to actually design these structures to be made of many, many individual parts, just like solar panels on your rooftop, for example, identical parts that are stacked inside the top of a rocket. And then you launch the rocket into orbit, where you release these parts to be assembled into a larger structure using robots in space. And in order to make a very large structure, enough to capture large amounts of power, you will likely need many rockets to launch a lot of parts into space to be assembled into a full solar power plant. And once that is assembled, then the sunlight is captured with solar cells, just like we do on the ground, converted into electricity. And then we have to convert it into a form that we can deliver it, beam it wirelessly down to the Earth. And typically that is done with radio waves. very similar to satellite communications or Wi-Fi. We convert it to radio waves, and then we beam that energy down to a user on the Earth where there's a receiver that captures that energy on the ground and converts it back into electricity and feeds that into the grid or any users that want to use that electricity.
This project does sound quite similar to Isaac Asimov's science fiction tale. Yet, unlike the system described in the short story, these panels would beam energy exclusively to Earth and not to other planets. But still, the idea of a solar farm in space, the role of robots in assembling it, and the vast amount of energy involved all echo Asimov's vision. Now, it's important to note that Asimov wasn't the first to come up with the idea of solar energy from space. As early as the 1920s, Russian scientist Konstantin Solyovsky had suggested that space-based mirrors could beam sunlight down to Earth. It wasn't until the 1960s that engineers began seriously investing time and resources into the concept. So what makes this type of energy so appealing?
Ideally, a mix of energy sources have three main characteristics we're looking for all at the same time. One is that they are secure and reliable and always available when we need them. Second is we would like to have that affordable so that we can afford to have that and use that energy. And third, we would like it to be sustainable, meaning that energy is both available for a long period of time and that it's not going to destroy our environment at the same time as using it over large periods and large amounts of it. So how to achieve all of these three in a energy source has been constantly the challenge that we have. And today, there aren't energy sources available to us on the surface of the Earth where we are satisfactorily meeting these three requirements. And so this is the challenge that we have today with the energy sources that are available and affordable. They're not clean. Or, for example, the clean ones are not always available when we need them in different weather conditions or at nighttime. So in order to find this ideal characteristics, if you go up into space where the sun is shining 24/7, you're able to capture clean energy in a reliable way that is available for the next 5 billion years. And you're able to have that in a secure and affordable way as well once we do this at scale. So that's the why of why you want to go up into space to capture solar, because you are able to finally solve the problem that you want for energy.
We still haven't found the perfect energy mix on Earth. Some sources, like fossil fuels, are readily available, but they are extremely harmful to our environment. Others, such as solar and wind energy, can claim to be environmentally sustainable, if not entirely reliable, as they depend on daylight or wind. And that's where space-based solar energy comes in as a potentially attractive solution. It could, in fact, provide a consistent supply of energy by harnessing sunlight continuously 24 hours a day. And in addition, it could offer a significant social benefit. Here's Francesco Contino, professor at the School of Engineering at the UC Louvain in Belgium.
If you look at the social resistance, local resistance to installing new onshore wind turbine through Europe and elsewhere, it's related to the fact that we don't want to have a wind turbine in the backyard. And this is a general fear. It's called NIMBY, not in my backyard syndrome. Of course, we need more and more renewable energy. So there is a need to install more and more renewable energy. And therefore, instead of installing them onshore, there is a tendency to install them offshore. Well, it's a little bit the same here. If you think of it, having those solar panels out there in space, well, they are in nobody's backyard.
At this point in the story, you probably have a pretty obvious question bouncing around your head. If space-based solar energy is so promising, why isn't it already above our heads today?
If you harvest solar energy and you are in space, ISS, a satellite, well, you directly use it. You are in space. We are not here at the same level. We are on Earth. And so the gigantic challenge will be to bring this energy back on Earth. And there are different possibilities. Most probably it will be wireless transmission, but then again, you face other difficulties, clouds. You also face the fact that you don't want to be in the ray of energy going back from space.
The other two major challenges around the development of space-based solar energy concern its economic and environmental costs. In January 2024, NASA published a report on space-based solar power and concluded that the two systems it analysed are very expensive and may produce greenhouse gas emissions comparable to existing renewable energy systems. Producing, launching, starting and maintaining such systems in space is not a cheap and easy task. Yet NASA also noted several opportunities to overcome these obstacles, improving solar cell efficiency, reducing the cost of access to space, and making manufacturing more efficient. And it's on these positive points that Sanjay prefers to focus his attention.
The way we were doing things in space, putting things in space with rockets that were only used once and then thrown away, as well as imagining assembling things with astronauts in orbit, which is also a very expensive way to do things, resulted in the cost that you would have to charge for the electricity to be so high that it wouldn't be worth doing. And that is what has fundamentally changed over the decades, and certainly in the last 10 years, thanks to the advent of reusable launches, as well as mass production of satellites and advancements in technologies like in-space robotics, servicing and construction. None of these technologies now have been used at large scale yet, but we see all the building blocks available that we believe in the next 5 to 10 years, with enough investment and effort, we can start to assemble these larger structures in space and make space-based solar power both technically and economically viable as well.
Yet his optimism isn't shared by everyone. Other experts argue that given the complex challenges and uncertainties of space-based solar power, it might be better to invest in existing terrestrial renewable energy sources and consider ways to reduce our energy consumption. Here again is Francesco Contino. We warned you, this topic is interesting, but it generates profound questions
and
debate. And in this complex scenario, where does the European Space Agency ESA stand?
It's a little bit like you are in a car, you are going towards a cliff, you're at 100 kilometers per hour, and instead of hitting the brake,
our podcast producer,
you
Alicia
look for
Carnevale,
the accelerator.
tried to reach out to ESA without
I'm
much
not
luck.
sure
But interestingly, before starting his private business, Vijendran worked for ESA for 16 years and was one of the leads of Solaris, a research and development program on space-based solar energy.
And not to
Let's remember that Sanjay Vijendran is not speaking on behalf of ESA, but is rather offering some insights into the Solaris project.
Some issues.
This was intended to do some intensive concept and technology development activities in order to understand the status of the technology and the concepts for space-based solar power so that Europe could make a decision in the near future about whether it should invest in a full development program or not. And so Solaris was begun at the end of 2022, which I led that program for a couple of years. And after the initial sets of studies that were done, the results were looked at internally within the European Space Agency to decide on the next steps. And the understanding and the position taken by the agency was that the technologies were still relatively immature for moving already to the next step of a demonstration mission, which is what Solaris was intending to work towards in the short time. And so the decision was taken not to pursue Solaris in the way it had been imagined, and to continue working on developing the technologies and improving the maturity some more before taking a further decision on where to go with space-based solar power.
Let's try to go through what happened together. At the end of 2022, ESA launched Solaris, a 3-year research and development program to prepare Europe for future decision-making on space-based solar power. Basically, a study to assess whether having solar farms orbiting above our heads can work and be cost-effective. This program was welcomed with interest and curiosity from the public and international media outlets. ESA commissioned private companies to conduct studies assessing the project's feasibility. Later, these studies were reviewed by ESA, which decided to halt the program in August 2024, as Vijendran said, because the technology was judged too immature to proceed with a demonstration. At the time this script was written on the 16th of October, it was difficult to find any information about the Solaris project, especially after April 2024. Typing Solaris on ESA's website search bar brought up some videos and images with descriptions, but other pages, like cost versus benefit studies, could not be accessed. Alice Carnevale asked ESA for access to the studies conducted as part of the project, but these were not provided within the requested timeframe. But if ESA has dropped the project, why is Vijendran still working on the development of space-based solar power in the private sector?
The results of the studies that were done by industry were very positive about the potential for space-based solar power to be valuable to the energy sector. They highlighted, of course, all of the major challenges that are still remaining that need to be solved in order to realize this in the next decade from the 2030s onwards. They assessed the costs as well that it would have at the beginning and then how those costs would fall in future. But it was really a decision based on the technological challenge going from where we are today to where we need to be to make space-based solar power economically viable. And that gap is still relatively large. And it's a decision about whether somebody wants to pursue that development right now to turn it into reality, or whether to continue to reduce that gap from a technological perspective first before planning on making a major project from it.
Sanjay Vijendran's company TerraSpark is not the only one in Europe working to achieve space-based solar power. If you're a regular listener of Euronews Tech Talks, you might remember that in one of our first episodes, we spoke with Martin Soltau, co-CEO of Space Solar, a UK-based company specializing in this same sector. He had high expectations for the terrestrial impact of space-based solar power.
Space is largely used for the benefit of Earth. A lot of what we've learnt about our atmosphere and weather and climate change comes from being able to monitor that from space and constantly monitoring over years and decades to build up the data that tells us about what's going on. What space-based solar power does is take this use of space for the benefit of Earth to an altogether another level. Now we're using space to actually solve the problems of sustainable energy generation and through space-based solar power.
These hopes are what some academic studies have tried to translate into research, providing data and context to bridge the gap between reality and aspiration.
The overall purpose try to understand what will be a possible role of space solar, in the European scale power system decarbonization.
You're listening to Dr. Wei He. Senior Lecturer in Engineering at King's College London in the UK. In August of this year, he published a study that attracted interest in both scientific and public discussions.
We use quite established Europe-scale power system model, and we also combine with the state-of-the-art estimation and designs of the space solar power from NASA report published in 2024. So by merge kind of two established knowledge and expertise, we try to build an integrated model to say if everything follows what NASA predicts, what will happen for the European power system. So what we did, we found like potentially depending on the estimation, performance, and cost of NASA, and space solar power can help reduce the overall cost of the European scale power system by up to, I think, 15%.
The study analysed the potential of a design by NASA for space-based solar energy generation, which is planned to be in use by 2050. According to the article, space-based solar power has the potential to reduce Europe's need for land-based renewable energy by up to 80%. And it could also save Europe money by reducing the cost of the whole power system by up to 15%. But Wei He's research paper is very clear. There are risks, there are limitations, and there are variables.
We acknowledge there is a great uncertainty about this kind of future technology. The challenge is more about scalability. So in the past, we probably provide something at like several hundred watt or several kilowatt, but now we are talking something about gigawatt and also multiple or very large scale space-based solar power. So scalability, how you can demonstrate, for example, like you can actually assemble and manufacture and maintain, such a large-scale space-based solar power plant in the space. So that will be very challenging. That's something, human have never done in the past. And also there are another kind of, I would say something about supply chain to the space. So for example, although everyone is predicting a rapidly, reducing cost of like rockets, of launching costs. However, also there are many how frequent and how much load we actually can transport into space. That's also a bottleneck.
According to Wei He's research, the economy of space-based solar power remains a huge challenge to its full-scale deployment. And that's why he prefers a balanced position in the debate.
It has a potential, and still it's a long way to go. So when we say investing, so I guess like we probably focus on what, at the current stage. Of course, I think that has a technology got great potential to bring a lot of benefits for European and many other regions decarbonization. But still, there is a lot of risk around that long-term return.
Well, that's it for this episode of Euronews Tech Talks. We hope we've shed some light, or at least provided food for thought on space-based solar energy. Perhaps you have more questions than before, which is quite normal, yet at least you'll have a few points to share at your next lunch or dinner with your geeky space friends. We'll be back in 2 weeks with another episode investigating the relationship between space and energy with space mining. Is that even a thing? And most importantly, do we actually need it? Thanks for listening. I'm your host, Jeremy Wilks. This series was created by Marta Rodriguez Martinez. This episode was written and produced by Alice Carnevali. The theme music is by Leo Lebrun. Sound editing and sound mixing is by Johan Breton. Our editor-in-chief is Niaz Samedizada. Thanks to James Thomas for reading Powell's lines in Isaac Asimov's short story Reason. If you aren't already, you can listen to this series on Apple Podcasts, Spotify, Castbox, or wherever you get your podcasts. You can also find us on the Euronews YouTube channel. If you're enjoying this podcast, please consider leaving us a positive review and, of course, sharing it. Thanks for listening.